Okay. So this says find the amplitude, period, and frequency for the function, then graph it on the interval from negative 4 pi to positive 4 pi. All right. So first thing I'm going to, oops. Well, this is part of the next homework set is these problems. So nothing was due yet with them, but they'll be due on Sunday. So if you haven't done them yet, that's not a big deal, but you probably want to get to them sooner rather than later. I would start by just listing my values for A, C, H, and K. Blake, you good with those?
I am good with those.
Okay. Anybody else with a question of how I came up with those values before I move on? So that's like my first step, just to get those in. All right, the amplitude is the absolute value of A, so that's just 2. The period is 2 pi times the absolute value of C, so that's going to be 4 pi now. And the frequency is the reciprocal of the period, so that's 1 over 4 pi. So far, so good. Next, it wants us to graph, so I'm going to start by writing my transformation map. So that's Cx plus H, and then Ay plus K. And I'm going to go use my key points for sine, since this is a sine function. So these we gave you in your notes. I remember them because I am a nerdy old math teacher that's done problems like this like so many times I have them memorized. So I'll go ahead and perform my transformation just by plugging things in. That's 0, 0. This would be pi comma 2. This would be 2 pi 0. This would be 3 pi negative 2. This one would be 4 pi 0 again. Now that I have these done, I'm going to go ahead and draw myself a graph. Now, the directions here ask me to graph this over the interval from negative 4 pi to positive 4 pi, which is no big deal. Notice that my x coordinates here are just going up by pi, so I'm just going to have 1 pi, 2 pi, 3 pi, 4 pi. So I'll just do something like that. And then we'll plot. So 0, 0, pi 2, 2 pi 0, 3 pi negative 2, 4 pi 0. And then we'll just repeat the pattern in the opposite direction. So there's my graph, something like that. Maybe I'll write the last thing on my scale so we can see what the tick marks are, or intuit anyways what they are.
So that's what the interval, like when it says graph the function on the interval of negative 4 pi to positive 4 pi, it's just the
range of x values you need to cover. Yeah, that's all it's saying. So no big deal. Basically the same thing that we did on worksheet 1, basically, right? Except you had to draw your own axis. Yeah, you know, no big deal. You're happy there, Blake?
I am.
Anybody with good. Anybody with a follow-up on this one? Who's next then? Tommy, we'll go with you.
Can you do number 11, please?
From the same sheet?
Yeah.
Sure. So number 11, it says graph this guy on the interval from negative 2 pi to positive 2 pi. Okie dokie. So I'm going to start the same way. The first thing I'm going to do on this one, though, is I'm going to make sure that I factor the inside here, because that way it's currently written, I can't pick out the value of h right away, because the leading coefficient on 1 is not, or the leading coefficient on x is not 1. So I'm going to do that. Any questions with how I did that little piece of factoring there? Okay. So my value for a is -3. My value for c is 1/2. My value for h is -1, or pi over 8. And my value for k is -1. So that's everything I need to write my function map. So cx plus h, ay plus k. And now this is a cosine function, so I'm going to use my key points from cosine, which again, I've given you in the notes, and I would give you on a test or whatever. You don't have to memorize these. I haven't memorized because, again, huge, gigantic nerd. Oh, I forgot to write the value for h in there. I don't know why I said h, but I didn't write h. Goofy. Okay. So let's just plug things in here. So I have -pi over 8, comma, -4. And that's going to be pi over 4 minus 1/8. So that's going to be 1/8. Right? 1/4 minus 1/8 is 1/8. You could also like add the fractions normally. 1/2 minus 1/8 is 3/8. And that's going to be 3 minus 1, so 2. That's going to be 3/4 minus 1/8. I think that's got to be 5/8. And that's -1. And then we have pi minus 1/8 is 7/8. And then that's -4 again. That feel okay so far? Okay, now I just need to draw the graph. So I'm just going to steal that appropriately sized axis. Put some tick marks on here. This says I have to go to -2 pi and +2 pi, but here we're going by 8ths, which is like kind of a pain in the tuchus. Oh, let's see, how is this? I mean, if I really wanted to be, we really want to do a good job, maybe we'll just put 16 of these stupid tick marks on here. Actually, I'm not doing that. I'm going to put 8 of them on here, and those will go by quarters then. 4, 5, 6, 7, 8. So that'll be 2 pi. So those are quarter marks instead of 8s. One, 2, 3, 4, 5, 6, 7, 8. Guess I put those ones closer together or something. All right. Not to scale. And then 1, 2, 3, 4. 1, 2, 3, 4. Okay. So -pi over 8, -4 is down there in between 1/4 or -1/4 and 0. I have 1/8 and -1, and 3/8 and 2, and then 5/8 and -1, and then 7/8 and -4, and then we're back, and there's there, and then there, oops, and then back down there, and down to there, and then be like here, up to there, down to there, down to there, back to here, back to here, down to there. So it looks something like that. Feel okay, Tommy?
Yeah, thank you.
Yeah. On the test or whatever, I'd give you an axis to build this on. You wouldn't have to draw your own, so it'd be a little less of a pain in the tuchus than that. Or at least things would be consistently scaled, where I can't apparently put tick marks the same distance apart on both sides of my axis there, but that's why it seems like it's getting wider there later on. Sedge is a bad drawer. Okay. Who's next? Happy to do some more if there's more. How you doing on writing the equations from the description problems? Those doing okay? It's probably the hardest thing we do in this chapter. Blake?
Okay, so when you are asking those questions, do you want us to construct both a sine and a cosine?
No, one or the other would be fine. You don't have to do both. I think on the answer key I give like several possible examples of answers, but there's like infinitely many answers for these things. But like an obvious one is good.
Okay, perfect.
Yeah, I think I usually give like 4 versions of answers. Is that right? I can't remember what I gave on those answer keys. Yeah, let's look real quick. Let's see here. So yeah, so I give like 4 different versions there. So 2 sine and 2 cosine, and depending on what we're doing there. Actually, no, that's just one of each there, because this is just the non-simplified version. So I guess some of them we're just giving the easy answer and maybe 2 versions of the easy answer, depending on how you chose points or whatever. Paul?
Did you do number 5 on versions?
Yeah, of course. That's what this time is for, you know? Is 5 on page 1 still? Yup. Okay. Let's pull that out. Put it over here. Okay. So 5 says construct a sinusoid. That means a sine or cosine function. Doesn't matter which. Where the amplitude is pi over 6. Well, that tells me that square root 6, not pi over 6. What am I saying? So that tells me the absolute value of a is square root 6. It says the period is 7 pi. So I know then that 2 pi times c is equal to 7 pi. So c is 2 over 7. I'm sorry, 7 over 2. And I always like to make my c's positive. Again, you could write an answer with a c as negative, but I don't think it ever makes the problem any easier to do it that way. So I would recommend against it. But if you give me the correct answer, you know, I will definitely be making sure that, you know, if it's something weird that I didn't expect, I'll double check it out with the graph or whatever to make sure that it's doing what it's supposed to do. Anyways, continuing on. So it says that I have a midpoint. So I would use sine function to do this, because I'm going to take from the parent function the point 0, 0, and pair that to the point on the transform function that I'm given. And I know that that's midline point to midline point. The one from the parent function goes minimum, midline point, maximum. I'm not given that kind of information about my midline point from the transformed function. So I'm free to choose it to kind of be any type of midline point that I'd like. So I would just choose it to be the same. You know, you could choose it to be the other kind of midline point too. I don't know why you'd want to do that, but you could. It just changed the value for A. So because those are the same type of midline points, the A is going to be positive. Because the x-coordinate from the parent function is a 0, I know the x-coordinate from the transformed function is going to be my h. And because the y-coordinate from the parent function is 0, I know the y-coordinate from my transformed function is going to be my k. So there we go. Paul, does that look okay to you?
Yeah, that helps.
Sure. Tommy?
Can you do number 9 on the same worksheet?
Sure. Oops. This one. Okay. So let's start by just kind of sketching a little bit of a picture to see what's going on here. Because here we're just given 2 points, right? I'm given that I have a minimum value at 10, -20 and a second maximum at 46.18. So it's going to have to do something like that, right? You good with that, Tommy? Okay. So I like to start by finding k first. So I know k is going to be like halfway in between those two. So it should be somewhere like there. So that's going to be like the average of the y-coordinates. So I'll do the y from the maximum plus the y from the minimum, and then divide that by 2. So -20 plus 18 divided by 2 is -1. The amplitude is like half of the distance between the max and the min. So that's going to be y max minus y min divided by 2. So that's going to be 18 plus 20. I don't know why I wrote the -20 first. That should be 18 plus a -20. It doesn't really matter. It still gives you the same number there. And that's 19. So far, so good. And again, if you're thinking about the absolute value of A, you could just think about the absolute value of the difference in the y-coordinates. It doesn't really matter which one you subtract from which. If you just take the absolute value of it, that would be fine to do also. So far, so good? Sydney. Sure. What I'm going to do now is I'm going to find the value for C. So I have to figure out, okay, how many periods do I really have drawn here? So if I go from here to here, that's one period. And then I have another half. You buy that? So I have 1.5 period is going to be the difference in the x-coordinate on the right minus the x-coordinate on the left. Or again, it doesn't really matter which one you subtract from which one if you just take the absolute value when you're done. You can think about it that way also. So that's going to be 46 minus 10. And I know a period is 2 pi times the absolute value of C. 1.5 times 2 is 3. So when I divide both sides by 3 pi, I end up with 12 over pi. And we always pick the C to be positive. Or at least I always do that. I'd encourage you guys to do the same. But again, if you didn't, there's still a correct answer where the C is negative. If you wanted to go that route. I don't recommend it, but if it's right, I'd mark it right still. And your work makes sense, some kind of sense. Tommy, you still good? Okay. The last thing we need to do is determine whether we're going to use a sine or a cosine here, find the value for h, and then figure out if a should be positive or negative. So in this problem, we're given maxes and mins, so I would use cosine as my parent function. So in cosine, I like to use the point 0,1, and it's a maximum. In my transform function, I could use either point. I'm given a minimum and I'm given a maximum. It doesn't really matter which one I use. I'm just going to use the first one that's listed, was 10, negative 20, which is a minimum. Because we're switching from max to min, that tells me my a needs to be negative. And because the x-coordinate for my parent function is 0, the h has to be the x-coordinate for my transform function. And there we go. Does that feel okay?
Yeah.
So the trickiest part there was probably getting the right C value.
That's what I should, that's what I messed up.
Yeah, so again, drawing the picture really kind of helps. If you didn't draw the picture to start with, I typically, if I thought about it hard enough, maybe in my head I would be able to come up with that, but it's super obvious once I draw the picture, and it just takes a couple of seconds to draw the picture, so. That's what how I like to handle it. Ariel?
Wait, so when you're doing finding the period, take how many there are and then flip it? Like, since there's like 3 over 2 in that one.
Well, I just thought about it as what I have here is 1.5 periods. So I just left it as that, and then I looked at the difference of the x-coordinates and then solved for C, that equation. But you could put the 2/3 on the other side straight away and see like pi over 3, or 2 pi C equals, 36 times 2/3 and start from that. That would be okay to do too. It's still doing the same thing, right? You just multiplied the 2/3 onto the other side straight away. Like, that's fine to think about it that way also. Is that? So again, like we're talking about doing the same thing. We had equivalent equations, right? Just one thing was moved to the other side. It's whatever, I like to count how many periods I have. That's a little bit easier for me to see visually than thinking about it. It's like, okay, 2/3 of that distance is one period. That to me is a little bit more difficult to visualize. But it's not wrong to do it that way. Probably at some point I tried to do it that way. It's still the equivalent, right? Just about whatever is easiest for you to kind of visualize. Who wants to go next? Do we have more that you guys want to talk about?